Friends, today we are going to dive into the wonderful world of the human brain, the most complex and mysterious organ in the entire universe. Imagine this. In your head is a device made up of 86 billion neurons, each of which can make up to 1,0,0,0,0 connections with other cells. If we tried to count all the possible combinations of neuronal connections, the number would be greater than the number of atoms in the entire known universe. But what's even more amazing are the strange and unusual things our brains do every day. Why can't we tickle ourselves? Why do we forget why we came to the other room? How does the brain create the sensation that time crawls like a turtle or flies like a rocket? Today we will reveal the most interesting secrets of our brain, which happen to us every day, but we do not even think about. This information will be interesting and useful for the whole family, from elementary school children to grandparents, because each of us can recognize ourselves in these amazing phenomena and better understand how our own brain works. The brain is constantly creating models to predict the outcome of our actions. This helps us react faster to the world around us. When we try to tickle ourselves, the brain knows exactly where and when the touch will occur, so it suppresses the sensory response. Interestingly, research has shown, if you create a slight delay between the hand movement and the actual touch, the person starts to feel the tickle. Researchers from University College London found that people with schizophrenia can sometimes tickle themselves because this predictive mechanism is disrupted. The same mechanism explains why we can't surprise ourselves with our actions or scare ourselves in the mirror. The ability to suppress responses to our own touch is evolutionarily important. It allows us to distinguish between external stimuli and our own action. In experiments with a robotic arm, people could tickle themselves if they thought the arm was being controlled by someone else, even if it was actually their own movements. During sleep, the brain replays the events of the past day in an accelerated fashion, a phenomenon called memory consolidation. The hippocampus, which is responsible for forming memories, is especially active during slow-wave sleep, when information is transferred to long-term memory. Studies have shown that rats in sleep repeat the routes they learned during the day, and their neurons are activated in the same sequence. Students who slept after learning new material memorized 40% more information than those who stayed awake. Interestingly, the brain is capable of solving complex problems during sleep. Many scientists and inventors have reported solutions that came to them in their sleep. The process of forming memories in sleep also involves cleaning the brain of unnecessary information, which prevents our memory from becoming overloaded. Studies show that even a short 20-minute nap can significantly improve the memorization of new information. When we stare at a word for a long time or repeat it, there is a temporary depletion of the neural connections responsible for its meaning. This phenomenon was first described by psychologist Leon Jakubowicz in 1962 and was called semantic satiation. Interestingly, it happens not only with words but also with images and even music, when traumatic repetition can temporarily render them meaningless. In bilinguals, this effect can occur in one language without affecting the same word in another language. Research shows that the phenomenon is stronger for words with concrete meaning than for abstract concepts. This effect is temporary and usually goes away after a few minutes when neural connections are restored. In psychotherapy, this phenomenon is sometimes used to reduce emotional reactions to traumatic words or memories. The olfactory system is directly linked to the brain's limbic system, which is responsible for emotions and memory, bypassing intermediate processing stages. Odors can trigger memories that are formed before the age of 3, while visual memories typically begin at 3-4 years of age. Studies show that people can remember up to 1,0,0,0,0 different odors, and each can be associated with a specific memory. The phenomenon of Proustian memory, named after Marcel Proust, describes how odors can trigger entire chains of memories and associated emotions. Interestingly, odor memories are virtually immune to distortion over time, unlike visual or auditory memories. MRI studies show that when familiar odors are perceived, the same areas of the brain are activated as when the original memory was formed. The ability of odors to trigger strong emotional memories is used extensively in marketing and aromatherapy. In childhood, time seems slower because the brain processes more new information and makes more new neural connections. As we age, most events become routine and the brain processes them automatically, which creates a sense of time speeding up. When under stress or in danger, time may seem to slow down due to increased activity of the amygdala and the release of adrenaline. Studies show that time perception also depends on body temperature. Time seems slower at higher temperatures. An interesting fact is that when we look at a watch for the first time, the second hand seems to freeze longer than usual. This is called chronesthesia. In an experiment involving a fall from a height, under safe conditions, participants judged the time of the fall to be longer than it actually was. The perception of time also changes depending on whether we are waiting for something or remembering past events. The doorway effect was discovered by psychologists at the University of Notre Dame, who proved that the mere fact of passing through a door creates a new memory episode in the brain. Our brains automatically divide the experience into separate episodes, using the change in environment as a signal to create a new mental folder. Interestingly, this effect is just as strong in virtual reality as it is in the real world. Studies show that people forget their intentions 2 to 3 seconds more often exactly after passing through a doorway than when traveling the same distance in the same room. This mechanism is evolutionarily useful because it helps the brain clear working memory for new information in a new space. In experiments, it has been found that returning to the original room often helps recall a forgotten intention. People with better working memory are less susceptible to the doorway effect. Their perception of the world around them is more susceptible to unexpected. Musical memory is retained longer than other types of memory, even with severe brain damage and dementia. Song lyrics are often memorized more easily than regular text due to the combination of rhythm, melody, and rhyme. Studies show that musical memories activate many areas of the brain at once, creating strong neural connections. Interestingly, people with amusia, music deafness, can remember song lyrics but are unable to recognize melodies. Children's songs are especially well retained in memory because they are associated with a period of active formation of neural connections. Listening to familiar music activates the same areas of the brain that are activated when recalling important life events. Musical memory can be retained even in patients with severe Alzheimer's disease. John O'Keefe, Maybrit, and Edward Moser won the Nobel Prize in 2014 for their discovery of positioning cells in the brain. There are special place cells in the hippocampus that are activated when we are at a particular point in space. Another type of cell, grid cells, creates a coordinate grid that helps us understand distances and directions. This system is so accurate that it can work even in total darkness, relying on internal motion signals and spatial memory. In professional cab drivers, the parts of the brain responsible for navigation increase in size with experience. Interestingly, this system begins to form in infants as soon as they begin to crawl. In Alzheimer's disease, these navigation cells are among the first to be destroyed. Our brains are evolutionarily programmed to recognize faces. It was important for survival and social interaction. Babies begin to recognize faces as early as a few hours after birth, showing the innateness of this ability. Studies show that people can see a face in as little as 33 milliseconds, even if the image is fuzzy. Interestingly, the areas of the brain responsible for recognizing faces are activated even when we see faces in inanimate objects. People with high anxiety are more likely to see faces in random patterns. This is due to increased activity of the amygdala. Pareidolia also extends to sounds. People often hear words in random noises or music backwards. This phenomenon is used extensively in product design and architecture to create an emotional connection with objects. In 1953, the cocktail party effect, the brain's ability to pick out important sounds from noise, was described. Our brains can process up to 35 different sound streams at once, but only focus on the significant ones. Interestingly, even when we are not paying attention to the conversation, the brain still picks up important words, such as our name. This mechanism works thanks to a complex system of neural filters in the auditory cortex of the brain. Musicians have a better ability to recognize individual instruments in an orchestra. Studies show that women are better at picking out important speech from noise than men. This ability deteriorates with age, which partly explains the difficulties of the elderly in noisy environments. The average duration of a yawn is about 6 seconds, and it is one of the few reflexes that begins in the womb. The contagiousness of yawning is related to the functioning of mirror neurons, the same ones responsible for empathy. Studies show that people with more developed empathy are more likely to yawn contagiously. Interestingly, dogs can be infected by yawning from people, especially their owners. Yawning helps cool the brain and increase brain activity, so it often occurs when fatigued or needing to concentrate. High-functioning psychopaths are less likely to exhibit contagious yawning due to reduced empathy. Even just reading or talking about yawning can trigger this reflex in most people. Here we are familiarized with the amazing peculiarities of our brain. Understanding these processes not only satisfies our curiosity, but also helps us to better utilize our own brain's capabilities. The amazing thing is that this is only a small part of what our brain is capable of. Many of its mysteries still remain unsolved, and scientists are making new discoveries in the field of neurobiology every day. Perhaps some of you watching this video will become so interested in how the brain works that you will take the next important step in understanding this amazing organ in the future. We hope you have learned a lot of new and interesting things. If yes, don't forget to like, subscribe to the channel, and share the video with your friends. Leave a comment what fact surprised you the most. Thanks for your attention, and see you in the next video.